Hello, I'm Joseph McCarthy of the Irish Abroad website. Welcome back to our series of programming tutorial videos framed around developing football statistics, specifically based on appearance data for the Republic of Ireland senior men's team. In this episode, we're going to look at two statistics. First, that the team Stephen Kenny selected to face Scotland in September 2022 had the lowest average age of any team to start a competitive game since the 1982 World Cup qualifier against Cyprus in November 1980. And following that, I'll show how in his 30 games in charge to date, Stephen Kenny has given 15 players their international debut, as many player debuts as Brian Kerr did in his 33 games in charge. Before we start, make sure you have cloned or pulled the latest version of the code from the repository on GitHub. I'll include a link in the description below. Since the last episode, I've reorganized the repo a little so the JavaScript library files are now in the lib directory, the JSON data files are in the data directory, and the files for each episode are in these episode directories. All set? Let's get started with the first stat. When Stephen Kenny named his team to face Scotland in September 2022, it had the lowest average age to start a competitive game since the 1982 World Cup qualifier against Cyprus, held in November 1980. To show this, we're going to start with a program that calculates a player's current age using their date of birth, then their age on a specific day, then the ages of each player in a starting 11, and from that the total age of the team and its average age. Finally, we'll compare the average age of each starting 11 in competitive internationals to prove the statistic. Start with an empty JavaScript file. First, take the player ID as a command line parameter. Remember, in Node.js, the first two items in the argv array are the node runtime itself and the name of the program that was executed, and each item after that, starting with the third item, is a command line parameter. Parse the ID as an integer and, using the getPlayerById function from the player's library, get the relevant player object. To calculate the player's age, use the todayJS function from the utils library to convert the player's date of birth to a day.js object. The day.js library itself will be needed to get the day.js object for today. Now we can use the dayjs.diff function to get the difference between the player's date of birth and today. By default, the function returns the difference in milliseconds, so add year as a second parameter to return the value in years. Finally, log all of this to the console. Now call this program with Robbie Keane's ID, 369, to see the player is 42 as this tutorial is recorded. The first step is now complete. The program calculates a player's current age from their date of birth. Let's expand this to calculate a player's age on any date. Add a second command line parameter and store it in a new variable, dateID. This new parameter will contain the date to calculate the player's age on, in the format YYYY-mm-dd, i.e. ISO standard 8601, as is used for date values in the players in games JSON files. Convert this value to a day.js object using the utils.todayJS function, and assign it to a new variable, date. Since the player's age will be calculated against the date variable, there's no need for the today variable, so remove it and refactor the call to the dayjs.diff function to use the date variable. Update the console log statement to include the date and call the program again, passing a date in the ISO 8601 format as a second parameter. And you can see that Robbie Keane was 19 on Saturday the 1st of January in the year 2000. Now that we can get the age of a player on a given date, let's update the program to get the ages of each player in the starting 11 of a given game. We'll use the playerRef attribute of each object in the starting 11 array to get the relevant player object, then use the date attribute of the game object itself to calculate each player's age. First, we'll need to get the game object for an ID passed from the command line. Remove the two lines processing command line parameters and replace them with a new variable containing the game ID. We're going to create a new function that takes a player ID and a date as parameters and uses the existing code to print a player's age. The today variable is no longer needed, so it and the day.js library can be removed. Import the games library, then use the getGameById function from the library to get the game object using the GameID variable. Use the utils.todayJS function to create a day.js object from the date attribute of the game object and then format it to be human readable. Add the levels library and use to get the level object from the level attribute of the game object, and from that the name of the level itself. Add the countries library and use to get the country object for the home and away teams in the game and the name of each team from both objects. Before we log each player's age, add the details of the game, i.e. the date, level, teams and the score, to the log. Finally, iterate through the game starting 11 array, calling the calculate player age function with the playerRef attribute from each item in the array and the game date as the date to calculate the player's age against. Run the program from the command line with the ID of a game from games.json as a parameter. Let's say 299, and you can see the ages of the starting 11 against Italy in the opening game of the World Cup in 1994. But this isn't exactly what we need. which is the average of the ages, not the ages themselves. In its current format, the calculate player age function only logs the ages to the console. Let's refactor it to return the player's age, then we can use the array.reduce function to calculate the sum of the player ages, and from that, the average of the ages. First, remove the console log statement and replace it with a return statement. Now, change the call to the forEach function of the game.starting11 array to a call to the map function to create a new array with the ages of each player in the starting 11 and store it in a variable called starting11ages. Next, we're going to use the array.reduce function to calculate the total of the ages. The reduce function hasn't been covered in the series so far. It's often used with the map function, but it differs from the map function in that the map function will use each item in an array to create an item in a new array, whereas the reduce function applies a function to each item in an array to create the result. This function has two parameters, the current result of the reduce function itself and the item of the array to be processed. In this case, each item in the starting 11 ages array, i.e. each age, will be added to the running total contained in the result parameter, with 0 as the initial value, and the final result being the total age of the starting 11. To get the average age, divide the total age by 11 and log this value to the console. Call the program with the same game ID as before, and you can see that the average age of the team that faced Italy in Giants Stadium was 28.63 years. But this isn't actually very accurate. If a player was 28 years and 11 months, then, since the dayjs.diff function is returning the value in years, the average is calculated using the value 28. So let's improve the accuracy. First, replace the year parameter to the dayjs.diff function with day to calculate the player's age in days. This means that the total age value is now going to be in days, and to calculate the average in years, an extra calculation would be needed. First, for clarity, rename the average age variable to average age in days. To convert this value to years, divide it by the number of days in a year, i.e. 365 and a quarter. Then store this in a new variable, average age in years. Finally, replace the variable in the console log statement with this new variable. Call the program with the same game ID again, and you can see that the actual average age of the team in Giants Stadium was 29.17 years, more than half a year older than the value calculated using the difference in years only. The program has evolved from calculating a single player's age to the total ages of a team and its average age, and is now ready for its final form, the average age of every Republic of Ireland starting 11. First, add the FS library and use it to read the game data from the games.json file, then parse the input as JSON and assign the games array to a local variable. Since the program is no longer taking user input, the game ID variable is not going to be needed, so it can be removed. Just like the earlier code was refactored into the calculate player age function, the remaining code will be refactored into a new function, calculate starting 11 average age, which will take a game object as a parameter and then calculate the average age of the starting 11 for that game. Now call the calculate starting 11 average age with each item in the games array. Running the program now shows the details for each game and the average age of the starting 11. But if you look at some of the early games, the average age is being displayed as NAN, i.e. not a number. Remember, the date of birth for some of the early Republic of Ireland players is not available, so when the utils.dayjs function is called with an undefined value, the resulting error value cannot be used to calculate the average. To resolve this, do a null check on the date of birth attribute, using the nullish coalescing operator, i.e. 2 question marks. This checks a value, and if it is null, defaults to another value. If the date of birth is null, we can default the value to the date of the game itself. This workaround does mean that the age of any player whose date of birth is unknown will be calculated 0, and the average age will not be accurate. Up until now, we've divided the total age by 11 because we assumed that the 11 values in the starting 11 ages array were all valid, but now that we know that any 0 values in the array are invalid. The number of valid ages in the array can be counted by filtering the non-zero values and counting the result. Assign this value to a variable, valid ages, and divide the total age by this instead of 11. Run the program again and scroll up to see that there are now average age values being calculated for the games that were previously giving errors. The console log is a little difficult to read now, so let's clean it up before continuing to develop the program. I've started using the console.table function in place of the console log. The table function takes an array and displays it as a table in the console, and it looks a lot cleaner on screen. This means that the game details currently being displayed in the console log statement need to be added to a JSON object instead. This object will be added as a new item to an array, which will be used as a parameter to the console.table function. We'll need to refactor the calculate starting 11 average age function to return a JSON object with the game details. First, remove the 2 logging statements, then return an object with each value that was previously added to the console log as an attribute of that object. Replace the games.forEach call with a call to the array.map function, and assign the result to a local variable. Then, log it to the console table. Run the program again to see the results displayed in a table. The program is always complete. The table in the console is the average starting age of every game the Republic of Ireland has played at senior international level, right up until the 2 friendlies against Norway and Malta in November 2022. To only display the average age for competitive games, add a filter call to the chain, using the levels.isCompetitive function to only process competitive games. Running the program again, you can see that the average age for the team that started against Scotland was 24.877 years. To show that this was the youngest team since the qualifier against Cyprus in 1980, add a final filter to the chain so that only games with the average age is less than 24.9 will be displayed. Running one last time, you can see that the last Republic of Ireland starting 11 with an average age of less than the team that started against Scotland in September 2022 was the team named by own hand to face Cyprus in November 1980, almost 42 years before the game in Hampden Park. The second stat to be examined is that following Mark Sykes' debut against Malta in November 2022, Stephen Kenny has now given 15 players their international debuts in his 30 games in charge, as many as Brian Kerr in the 33 games of his reign. We're going to start with a program to determine the manager that gave a specific player his debut, then develop this to get the manager that gave every Irish player his debut, and then finally reduce this to the number of players who were given debuts by each manager. Once again, start with an empty JavaScript file. This program will take the player ID as a command line parameter. Use the player ID as a parameter for the getPlayerById function in the players library to get the relevant player object from the player's JSON file. Add the games library and use the getPlayerCaps function to get the player's caps. The first item in the caps array at index 0 is the player's debut, and remember, this is a game object. Add the manager's library and then use the date attribute of the debut object as a parameter for the getManagerByDate function to get the manager in charge for the player's debut. Finally, log both the player and manager's names to the console. If you call the program with Robbie Keane's ID, 369, you can see the striker was given his debut by Mick McCarthy. Try this with a few other player IDs to see who gave each player his debut. The next step is to expand this to get the manager who gave every player his debut. We're going to do this by iterating through each item in the player's array from the player's JSON file, and then use each item as a parameter to a function developed from the existing code to log the details to the console. First, use the FS library to read the player's JSON file, then parse the contents and assign the player's array from the file to the local variable players. Since the program is now using the player's array and not taking input from the command line, there's no need for the player's library or the lines of process command line arguments, so they can be removed. We're going to refactor the remaining code into a function that will process each item from the player's array, i.e. each player object, and then log the player's debut manager to the console. Now use the array.forEach function to call this function for each item in the player's array. If you run the program again now, it fails, because the debut object is undefined for some players. These are players who have been named substitutes in games, but have not yet made their debut. Add a check that the player has made at least one appearance, i.e. that the caps array has at least one item in it, and run again. Still failing. This is because of the players who made their debut before the FAI appointed a full-time manager in 1969. The manager object for these players is undefined. In order to handle this case, we can use the optional chaining operator, i.e. a single question mark, on the manager object being logged to the console, so if the object is null, then undefined will be displayed. Running now, you can see each Irish player and the manager who gave him his debut. Instead of logging each result to the console, we're going to refactor the getPlayerDebutManager function to return an object with the player and manager name, and use the array.map function from the player's array to create a new array with these objects. First, create the return object from the function with the player name as an attribute. Next, remove the console log statement and add the manager's name as an attribute of the return value if the manager object is available, again using the optional chaining operator, and return this object from the function. In order to create the new array, refactor the array.forEach call to array.map, then assign the result to a local variable, and finally display this as a table in the console. Although it's not necessary, the getPlayerDebutManager function should be renamed to make it easier to understand. So rename it to PlayerToDebutManager, then save and run again to see the table. As you can see, there are a few players in the table with an undefined manager attribute. These are players who have either not yet made their debut, or made their debut when there was no full-time manager, and these need to be removed from the final result. So add a filter to the call chain to only include objects with a defined manager attribute. Run it again to see the table is now only populated with players who have made their international debut. The first half of this stat has now been completed. The array of players and debut managers has been created, and now this is going to be used to create a new array of objects containing each manager and the players he awarded debuts to. First, create the reduce function manager to debut players. We're going to find the item in the result array with the same manager as in the item parameter. The find operation has two possible results. Either the item in the result array containing the same manager name as the item parameter, or undefined if the result item does not exist yet. If the item exists in the result array, then simply add the player from the item parameter to the array of players given a debut by this manager. If the result from the find operation is undefined, then the item has not yet been added to the result array, so it must be created before the player can be added to the list of players given debuts. First, add the undefined check for the manager. Now, create a default object containing the manager from the item parameter and an empty players array, and add this object to the result array. With both cases covered, return the result array including the changes just made. Believe it or not, this is almost finished. Add a call to the players.reduce function to the call chain, with the manager to debut players function as the first parameter and an empty array as the second parameter, as the initial result object. If you run the program now, you'll see the table of managers and the players they gave debuts to, but we're looking for the number of players, not their names. Add a function to process the results from the manager to debut players function. All that is needed is to return an object containing the manager and the length of the players array. Add a map to the process result function to the call chain, then call the program one last time. As you can see, Stephen Kenny has awarded 15 players their international debut, the same amount as Brian Kerr. I hope you've enjoyed this tutorial. It's been a little longer than I had hoped since the last one. I hope that the wait for episode 4 won't be as long, and leave a comment below if there's anything you would like me to cover in it. Like, share and subscribe, and ring the bell to be notified when it comes out. And finally, as always, have fun.